Now we do average value of function. So this one has a lot of small topics. So first we talk about the arithmetic mean. Then we talk about the step function arithmetic mean. Then average value of a function, basically a continuous function in an interval. Then we show how this is actually an extension of the concept of an arithmetic mean, like the average value of a function in an interval, the geometric interpretation of that, and then we got a weighted mean, and then the integral form of weighted mean, and then two examples, one in physics and one in probability. So let's go ahead and do that. So first we come to the average value of a function. This is the arithmetic mean. Basically, there are, let me write down the formula. We want to take a number, the arithmetic mean of those numbers is a bar, which is the, and say if you want to take a distinct value of a function, a or value at in different points. Do k equals x. Then arithmetic mean of the function values. So then we come to definition like of a function. The main reason why we don't use, because this is finite, so this is in an interval, so there can be infinite number, but in that interval. So therefore, we come to prerequisite that we integrate on AB, define AF such that average value of F on AB with formula F equals the difference in the integral u minus a from A to B such of x dx. So this is the formula of that. And basically say we have geometric representation. Interpretation. Here we have what's happening into p minus c. So this average value, say from a of f, okay, and then we have our interval b and a, some value. So then this is technically a box. We take the area of that. So this box is actually equal to f plus dx, which is actually the ordinate step, near ordinate step. The area of the ordinate step. So that's basically the geometric interpretation. Now say we have a step function f, okay, n equals subinterval, which we know the standard into such that xk equals a plus k minus a plus k equals 0 to n minus that this does equals k is x xk, and also the difference is so then let's go ahead and plug in a formula. This is dx equal to 1 by n. Okay, equals to, let's see, which is basically at each step interval, at each step or interval, we take that value and divide by n. Average here is equal to arithmetic mean of x1, xn on each interval quantity. Then we come to weighted arithmetic mean. Weighted is equal to the mean of each of them have a weight. Let's choose at least one is non-zero weight equal to that. Roughly clear equal to 0 for at least one k. Also get division by 0 and that's not possible. So then the integral form of this is equal to the integral thing. Yes. The technical form. So if you take it an example, t equals 9, or multi-to engineering depends if you're in India or America. So say the mass of a rod. Here we have a rod like this. From the coordinate axis, this is the origin, and this is x. Okay. The mass of a rod from 0 to some x, where rho is the mass density, and this is a non-uniform rod, meaning the density keeps varying. Really, sometimes be more dense or less dense, and so forth. So then, mass of the rod, and this is the mass density. So the integration of mass density. And now we just have a neat looking thing called the first moment, generally of the rod about 0. So if you want to find the center of mass where the weight acts, xm, well, that is equal to the weighted average. Because all of them. It looks familiar where rho of x is like the weight. Let me see this example. It goes. And then this is called the second moment because of this is called our moment of inertia, where it rotates when it's rotating. That's where the mass acts. You can see. So this gives us a formula radius of gyration. R, where R square is equal to 1. We will have it of second moment. So also, example, in probability, we have second moment, which is f of x, right? Now this same interval a to b is actually something called the expectation, where for each x on AB, f of x is the probability of x occurring for some function. And this whole integral not without x is equal to 1. And similarly, something called varying, how far the values are from each other, is actually the second moment, if I'm not wrong. I'm not sure exactly. But yeah, it's varying. And that's another example.